Welcome. This is the first video that I'm going to do on descriptive statistics. This is going to be part of the class for business analytics as well as for statistics. And in this first video, we have a very simple concept that we're going to be discussing, which is the average, the sample mean. And what I want to concentrate on today is three different ways with which you can get descriptives in Excel. So I have prepared here a data set for you that consists of two variables, variable x1 and variable x2. And we have 5 observations. We can see them over here. Now what we want to do is we want to find some way to estimate the average, and we all know the formula for the average. The formula says that the x bar is equal, the sample mean is equal to sum of xi, where I is equal 1 through n. And since I have 5 observations now, this is equivalent to saying x1 plus x2 plus x3 plus x4 plus x5 divided by the number of observations, which is equal to 5. And if I do the calculations, I will find that this is equal to 5. I can find this in Excel. The first way to find this in Excel is to write equal to average, and then I'm simply going to highlight all the information that I want to include and press enter. Now the way that we usually depict this in a diagram is by a horizontal line. In other words, if I have my x values over here and the number of observations over here, then the x bar, which is equal to 5, is simply going to be a straight line, a horizontal line that goes through the value of x is equal to 5. This is one way to get the average. However, there is a better way to get the average, and that's what I want to show you now. If you go to the tab called Data, you will find to the right Data Analysis, which you can click, and then you will see over here that you have a number of options. You can do ANOVA correlation, descriptive statistics, you can find the covariance. We're going to go through all of these in this class. However, we're going to do all of this one step at a time. At this point, we are in the descriptive statistics. Now, in order for you to have the data analysis option up in the data tab, the first time that you're going to use data analysis Toolpak, you're going to need to go to File, Options, and then you're going to go to Add-ins. So File, Options, Add-ins. And once you click Add-ins, you're going to see over here the Analysis Toolpak and the Analysis Toolpak VBA. If you click on the Analysis Toolpak and click on Go, you're going to get a new window. And make sure that you have Analysis Toolpak checked and press OK. As soon as you press OK, this Data Analysis option is going to show up on your Data tab. In my case, it will not make any difference since it is already here. Now, how do we use the Data Analysis Toolpak? First of all, I'm going to click on it, and I'm going to get the window that gives me the options that the Data Analysis Toolpak provides us with. And then I'm going to choose Descriptive Statistics, and I'm going to press OK. Now, the first thing I have to do is I have to choose the input range. And in my case, the input range is going to be variable x1, and I am including the name that I have given. However, if you include the name that you have given, make sure that you also have the labels in the first row checked. You can also click on Summary Statistics, Confidence Level, kth largest, kth smallest. When you first click on it, these are going to be unchecked. You need to check them on your own. And then it says Output Range. So the question is, where do I want my results to show? And I am going to put the data, the results in N2. So let me press OK. This already says N2. And there it is. My mean is equal to 5. The average value that we see over here is exactly the same. Now, as you can see, we get a number of other statistics, which we will describe in future videos. We're going to be talking about the standard deviation, the median, the mode, the sample, kurtosis, and so forth, so that you can understand what all of these measures are and how they can help you with data analysis. Now, there's a small problem with the data analysis Toolpak, and that is that it doesn't immediately renew the values if you change the numbers. For example, if I would like to change my observation number 5 from 7 to 50, as you can see, the data does not change. So what can we do about that? Well, in the file that I have created, there is a sheet called core plus descriptives. That means correlation plus descriptives. And this is going to be uploaded on the website. You can download it and you can use it whenever you want. Now, I'm giving you directions over here, and I'm telling you that you have the option of getting information for up to 10 variables, which you can name. So, for example, like I can change the name of the variable for the first variable from x1 to y, from x2 to y1, and so forth. And immediately the values on the output table are also going to change. And you can also add up to 200 observations. Now, as you can see, you get immediately all the descriptive statistics that Excel also provides you with. However, those get updated every time that you change the data or add more information. For example, if I add over here the value 10, you can see that immediately everything gets updated. 12, 15, 25, depending on your data. So you can use this file whenever you want, and I will be using this file for the remaining descriptive statistics that we will be discussing. Now, so far what we've seen variables x1 and x2, both of which, as you can see over here, have an average value of 5. Now, that means that if I were to solely rely on the average in order to get a good feel about my data, it would not really be good enough. In other words, I will need some other measures in order to get a full description of what my data looks like. Let's take a look at the data for a second. Let us say that both x1 and x2 represent the returns on stock 1 and stock 2. So for example, stock 1 return was 5% for the first year, 6% for the second year, and then 7% for the most recent year. If I were to plot this data in my diagram, then I would have 1 point exactly at 5. I would have the value 6, 4, 7, and 3. If I were to plot, however, variable number 2, as you can see, I have the value 5, then I have the value 5.1, which is very close to the mean. I have the value 4.9, which is also very close to the mean, 5.2, and 4.8. As you can see now, the second set of data has a lower spread. And simply knowing the simple arithmetic average for x1 and x2 cannot give us enough information. And that's why in the next video we're going to be discussing the standard deviation, which is going to tell us how spread out the data are from the mean. So for example, in the first case, we can see that S1 has a value of 1.581, whereas in the second case, the standard deviation has a value of 0.158. As you can see, when the data is less spread out around the mean, the standard deviation is smaller. When the data is more spread out, as is the case with variable x1, then the standard deviation is larger. So in the next video, we're going to clarify these concepts with a second example. We're first going to estimate the standard deviation by hand, step by step, and then we're going to see how it can help us on deciding which one of the two stocks we should buy, given, for example, that we are risk averse.